Hello. Today I said we'd go over GUI programming, but I have a disclaimer. We're not going to go very deep into GUI programming. The reason is because this tutorial is more, or the series is more about how to think about Haskell as opposed to just, this library does this, that library does that. I personally find making those kinds of tutorials extremely boring, and I just don't think they're very helpful. You can Google it. So what I thought we'd do is we'd use quite an interesting library, a declarative UI library based on GTK, and we'd just do a simple Hello World application because that's enough to really teach you the way in which declarative UI programming works, or at least this type of declarative GUI programming. We're not doing anything functional reactive or anything like that. We're just doing sort of bog standard declarative. So I have taken the liberty to pre-make some files, but I'm going to show you what I've done. So first of all, we need to look at the cable file. So finally, I've changed some things in here. I've added the -threaded to GHC options. So this is just going to pass -threaded to every GHC command. The reason why is because the library we're going to use uses a lot of threaded stuff, and we need to enable that explicitly in the compiler. And I've added a bunch of build depends. Text, GI, GTK, declarative app simple, GI, GTK, declarative, GI, GTK. I think that's all we're going to need. Again, these are extremely improvised. I've also changed the main.hs file a bit. So I've added these language extensions. Now we're not going to go over so much what they do because I'm going to do a separate few tutorials on language extensions and some of them, and I'll explain them better there. But essentially, Haskell has a lot more features than it lets you know about initially. The reason why is because the Haskell compiler, without any language extensions, has to implement the Haskell 2010 standard. But the Glasgow Haskell compiler is kind of this amazing tool for research into language design. And if you want to add a feature to the compiler, you add it as a language extension, which you enable normally here in the file, but you can enable them globally in the Cabal file. I've also added some imports. So we're going to need control.monad, these GTK ones, hiding. So the reason I have this hiding and then a list of things is because we have to, there are some conflicts in constructors and functions between GTK and GTK declarative. So I hide them. I think that's easier than choosing to import individual functions and constructors. Okay, so I've also just run Cabal v2 build. The reason why is because it's going to go and it's going to grab a whole load of dependencies the first time you do it, and it takes ages. And I'd rather not. I'd rather not record my screen when it's downloading and compiling all of these, because those dependencies have huge numbers of dependencies of their own. If you go on the GTK declarative website, it will tell you that you'll need some things installed on your computer beforehand, like the GTK3 libraries. So, take this tutorial with a pinch of salt. You're going to have to do a lot of Googling. Right then. So, let's do some code. So I guess the Hello World equivalent in GUI programming is that classic click me button that just says thank you. So that's what we're going to implement. But we're doing it in a declarative way. So declarative GUI programming works in a really different way because we completely remove the idea of state or global state. I was about to declare a data type called state, and that would make no sense. But we remove the idea of global state, and so we can't do things like just update the name of a button on the screen. Because that would imply that there's this global state that contains the name of your button. So instead, the way you think about it is you have a sort of a state data type, and we have a function which will go and it will take whatever's in that state data type, and it will use that to return another data type that describes what's going to be on the screen in its entirety. No changes, no updates, just its entirety. And then we have an update function that will take an event, a state, and it will return a monad of sort of a new state. And so the general idea is that the view, the general idea is that the monad is used to find the difference between two calls to your view function. So we have sort of two data types, one that represents what's on the screen currently, one that represents what you want to be on your screen. And it will find the difference between them and then update as little on the screen as possible. So it's much more efficient than just doing, redrawing the screen each time. They thought of that. They've made this declarative programming quite efficient. But in case that made no sense, we're actually going to do it. So first thing we're going to do is we're going to describe the possible states that our program can be in. So we're going to make a data type, state, and I guess it's just not clicked and clicked. If it's not clicked, the button will say, click me. If it's clicked, the button will say, thank you, like that. And then we need to think about the different events that could happen in this program. So we define a new data type, event. And I guess there's the button clicked event. And there's also like closing the window. So I'll have a close event. So I think the next thing to write would be the update function. So I'm going to call it update prime. You'll see why at the end, why I've got the prime there. And so this is of type state to event to, I think it's transition. I think transition state event. We'll find out soon enough. Let's have a look. I can tell you pretty quickly if that's correct. Undefined. Is that correct? Is that correct? Yes, that is correct. Okay. So transition here is our monad. So first of all, we don't actually care about what state the program's currently in when either button clicked or close is emitted. So we're actually just going to ignore the state. And then we're going to write what happens if we close, if the close event is emitted. Well, we're going to exit the program. What happens if our button click, is emitted? Well, we're going to transition, and we're going to move to the clicked state, and we have to return nothing. So what that return nothing is you can say and emit a new event, but we're not going to emit a new event, so we can just ignore it. So you can. So I think that part is of type transition maybe state, but we don't want to then emit another event, so we're just going to return nothing. Cool. So you can see how that works. Nice and simple. We kind of have how the program updates itself. So the next thing is we're probably going to need to draw something. So this is this UI toolkit dependent how this goes about. But the way I like to do it is we're first just going to draw the window. And the reason why is because draw window is where everything's in a window. So I like to separate that out from sort of the heavy lifting of the program. So draw window, and it's going to take, so everything in the view function is like of state to normally it's like widget event or something. But of course, we're just going to pass through the state and whatever we're going to draw inside the window. So whatever we're going to draw inside the window is going to be, we'll call it widget, and then it's going to take the state. And I'm just going to type this about bin window. So in this library, possibly in GTK as well, there's an idea of sort of containers. And a bin is something that contains just one thing, and it's going to contain our window. There's also things like list views, which sort of vertical list thing. There's grids. There's notebooks, which are sort of tabbed pages. You can see how to use all of them on the GI GTK declarative website. But a bin is just going to contain one thing, and that's going to be our window. Now, the next thing we do, and I like to go into a new line for this, is we have to give it some properties. So we're going to give it a title. So hashtag title equals, and we'll go for hello world. Nice. Now that hashtag is actually one of these, comes about through one of these language extensions, overloaded labels. The reason why is because there are so many widgets that we could have a title property for, and we don't want a new name for each of them. So that hashtag essentially gets replaced with maybe the name of the data type, but it allows you to reuse title, and it makes the UI kit a lot easier to use than having you don't have to type window title or whatever, or button title, or you can just type hashtag title in all of those cases. So that's what that extension does. It's quite useful. Now, the next thing we would probably want to deal with is we want to emit an event, the close event, if it's closed. So it would be on hashtag delete event. How do I know it's delete event? I Googled it quite a long time ago. And then, yeah, actually, this is a bit of a weird quirk about this library. I can't just type close. If I type close, as I will demonstrate, it will just error. Hopefully for the right reason. Yeah, so it says couldn't match GI GDK3 blah 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 with bool event. What's going on? What's going on? What I always find is a lot easier to do in this case is whenever you can emit an event, put an underscore and compile it. And the reason for that is the underscore is known as an signed hole. And so it gives you quite a nice warning when you compile it, or an error when you compile it. Here we go, found hole. And it tells you what that underscore should be of type. So the underscore should take an event and return a Boolean event. Bit weird. Bit more complicated than you expected. So I'm going to fill out something of that type. So const, that's not how you spell const. Const just ignores the first argument. So this is like defining a lambda, but ignoring the argument. And I'm going to give it true for the bool. And I'm going to give it close for the event. Cool. And we'll have, and afterwards we want to have our widget and pass a state to it. Nice. So that should build just fine. It's not going to do anything because we've not changed our main function. But it's good to build as you go along just to make sure you've got stuff correct. So next we'll have our draw body function. Ooh. So draw body. So our draw body function is going to be of type state to widget event. So we're going to want to have, this time the state matters. So draw body, and we'll start with clicked. Clicked is probably easier. So if the state is clicked, then we just say thank you. So it's going to equal widget. So this is like bin, but what follows is a widget, and it's going to be a button in this case. That's come from our GTK, GI GTK library. Again, we can give it properties. So I'm going to do just that. I'm going to go hashtag label, and that's going to equal thank you. Nice. And then we'll do the other one, draw body, not clicked, must align, equal signs, there we go. Pretty similar, widget, button, and then we have the label equals click me. Oh. Now we also have to handle the click event. So on, and then clicked, and then let's have a look, see what we actually need to put here. So if we build this, we should have another signed hole. Let's have a look. Bit of waiting. Oh, there we go. Found hole. It's just of type event. So the button clicked is a nice easy one. So the event that we're going to return is button clicked. Nice. So you can kind of see we made a function which draws the entire screen. But the only difference between the two is the label. So what this transition monad does is it sees what the current data type that describes the screen is, which might say click me, and then it sees the next state, which is where it says thank you. And but because we've not drawn anything to the screen per se, we just have two data types that describe the screen, it goes and it has a look and it sees that that is the only difference. So the transition will only update the label on the button. So we're having this very zoomed out view of UI programming. We've removed all of these complexities, but we haven't actually made it any more inefficient. But still, we've not changed our main function. So we should go and do that now. So void run app. So let me see if I can. This is going to error, but I'll show you what void does. So if I just import, so this one came from control.monad. If I show you the type of void, it kind of takes a functor, but in this case it's a monad, and it just ignores whatever the output was. And that's nice because run returns the state, the final state before it closed, before it exited. And we just don't care. We just don't care about the final state. So we use void to turn it into unit, which is this type, because main is of type IOUnit. So that's just to make sure the types match up. Cool. Run is part of the GUI/GTK thing, and it just takes a data type, app. And app describes our application. So we have to give it a view function. Now our view function is going to be draw window and then draw body. So this is one function here. Draw window takes a widget, a draw sort of, yeah. It takes a widget function, a widget function and a state, and at the end, inside the window, we have the widget and the state. We apply the state to the widget or whatever. So this just has the body, it types well. Next, we have an update function. Oh, I'm really struggling with spelling today. So you can see now why I had update prime. It's because update's taken here. It's already defined in GUI/GTK, declarative. So update prime. We need to tell it what our initial events are. In case you want that, I don't. So we're just going to have an empty list of events. And our initial state Oh, the alignment is killing me. Our initial state is going to be not clicked. Cool. So I think that is everything. I think that's going to work. Let's have a look. Build it. You see, I'm not using v2-build. That's because sometimes, depending on how new your Cabal version is, build does the same thing as v2-build. The idea is that v2-build will always do the same thing. Right, it built though. So Cabal run. And hey, let me drag this so you can see it. We have a graphical application. Click me. Thank you. And when we hit the close button, it closes. Amazing. So there we go. I hope this alluded to what declarative programming in Haskell can be like. It might have been completely obvious to you that I don't do this very often. I tend to use a TUI framework called Brick, but graphical application programming has never, well, it's never come up at work. I'd say that Haskell's GUI kits are somewhat limited at the moment. It doesn't have much of an ecosystem around them. I mean, GUI GTK declarative is genius and very good, but there's not many options. The reason being that Haskell tends to be used in projects where failure must be impossible. And they just don't tend to be graphical projects. They tend to be banking software. They tend to be, I know Tesla use it for their autonomous driving software, the critical path. I saw a job thing on Reddit. So it tends to be in non-GUI places, and as a result, it doesn't have much of a GUI ecosystem. But yeah, there we go. I hope you enjoyed this tutorial. I hope you got something out of it. I will see you in the next tutorial where we move on to something that I'm a bit more comfortable with, which is writing interpreters. Okay, see you then.